So resonance structures are structures that are interchangeable, they're equivalent, and usually there's delocalization. So as an example of a resonance structure, we will see that the -3 formal charge is delocalized across all 4 oxygen atoms, all 4 outer oxygen atoms. So let's draw the Lewis structure of phosphorus. So P is happy at 5, oxygen is happy at 6, but we have 4 of them, so 6 times 4 is 24, and then -3 means we've gained 3 electrons in order to become the phosphate ion. So 5 plus 4 is 29. 29 plus 3 is going to be 32. So our goal here is to get 32 valence electrons, across the phosphate ion. Well, the center atom here is going to be phosphorus because we don't know which of the 4 oxygen atoms certifies itself as central. So phosphorus is going to be the central atom in this particular case. All right, so we'll make our central phosphorus and we'll put 4 oxygens around it. Okay. Now PO4 minus 3, okay, so remember again our situation. A single bond to an oxygen will have a minus formal charge. So again, that calculation is this: 1, 2, 3, 4, 5, 6, 7. Oxygen is happy at 6. 6 minus 7 is -1. So this outer oxygen here will have a minus formal charge. We'll do that for this oxygen as well. Okay, so now we have a -1 and -2, and then we'll do that to this oxygen as well to give it a -3 total formal charge, and this is not minus formal charge. If we put a double bond here, that is to say we take a lone pair, make a double bond, we have 2 left over, and that will have a formal charge of 0. So this oxygen, this topmost oxygen, 1, 2, 3, 4, 5, and 6. So oxygen is happy at 6. And the formal charge of that oxygen is 0. By the way, the octet rule is also going to be satisfied for these outer oxygens. Let's just do really quickly the octet. 1, 2, 3, 4, 5, 6, 7, 8. So this satisfies the octet with the double bond to the oxygen. How about the single bond oxygen? 1, 2, 3, 4, 5, 6, 7, 8. The octet rule is satisfied for the single bond with the oxygen. Now let's look at the formal charge for this phosphorus. 1, 2, 3, 4, 5. Phosphorus is happy at 5. 5 minus 5 is 0. The only thing here is that this phosphorus has an expanded octet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the octet rule is expanded, but that's okay. Okay, really, it's more important that you minimize the formal charge, and we got a minimal formal charge of -3, and the problem has a charge of -3. Here's where resonance comes into play. You see that double bond. The double bond is on top, but it could just as well be on the left-hand side. It could just as well be on the bottom side. It could just as well be on the rightmost side. So here's one of the resonance structures. Let's do the other 3. So let's get the double bond, I don't know, just let's just get it on this side. Okay, this side of the phosphorus oxygen atom. Okay, so the double bond now is here, so we're going to have an oxygen double bond to a P. Okay, so this goes here, it kicks this out there. You just got to be careful you don't mess things up. And now I didn't touch these rightmost and bottom oxygens. Okay, so my -3 is still there. So I have my double bond. Let's highlight the double bonds in pink. So I have my double bond there, the double bond top, left. Let's have the double bond to the right. So we'll move this pair of electrons here, kick this guy out. So our another resonance structure is going to be shown here. The double bond now is on the leftmost side. Okay, still got my -3 there, so I'm good. And then finally, double bond on top, double bond on the left, double bond on the right. Let's have the double bond on the bottom. So put this lone pair of electrons here, kick this back out, and this is what seems to me my final resonance structure for phosphate. Still retain the -3 formal charge. Now the double bond. Don't forget to close the brackets here. Okay. The double bond here is now up at the bottom. So the key word here is delocalization. The key word here is delocalization. Look at the double bond, how it's delocalized across all 4 outer oxygen atoms. Notice the formal -3 formal charges is also equally delocalized across all 4 oxygen atoms. A very stable structure because of the resonance. So usually molecules that are resonance stabilized are very, very stable in nature.